The historical record presents a clear contradiction in the metal. If you examine the Boeing B-29 Superfortress parked at the Hill Aerospace Museum, the paint dictates one specific legacy. The nose art claims the identity of straight flush. That aircraft secured its place in aviation history on August 6, 1945, flying weather reconnaissance directly ahead of the Hiroshima strike. But documentary evidence proves that the original straight flush, carrying serial number 44-27301, was flown to Davis-Monthan Air Force Base storage and permanently destroyed by scrapping in July 1954. The original airframe no longer exists. The aircraft sitting in Utah is not the original straight flush. It is an authentic surviving B-29, displayed in commemorative markings that represent a different operational history. The true identity of the recovered bomber is serial number 44-86408. It is a Martin-built B-29 Block 55 airframe. The historical justification for using this specific machine relies on an exact chronological overlap. The aircraft was delivered to the United States Army Air Forces on August 6, 1945. This means the substitute airframe entered the military inventory on the exact day the original straight flush was assessing target visibility over Japan. The recovery and preservation objective here is not the salvage of the genuine Hiroshima veteran, because that is physically impossible. The objective is the preservation of the 509th Composite Group legacy through a later B-29 airframe delivered on the same date. But the substitute was not structurally identical in every respect. Straight flush was a silverplate aircraft, while 44-86408 was a standard B-29 Block 55 airframe. Ultimately, this airframe was repainted to serve as a permanent memorial to that specific combat group. Before it became a historical stand-in, serial number 44-86408 had its own distinct operational history. Following standard post-war service, the bomber was transferred to the Dugway Proving Ground in Utah in 1953. It was not sent there for storage. It was positioned on the high desert floor as a derelict target for chemical munitions testing. The airframe served as a full-scale ground test vehicle for various chemical warfare agents. The surviving public record does not establish the precise agents, the detailed objectives of the tests, or whether the pressure vessel was sealed or pressurized during those trials. Once the testing concluded, the airframe was simply left in place. This deployment created a severe operational constraint for any future recovery team. An aircraft subjected to military chemical testing cannot simply be approached and dismantled. The primary hazard mitigation constraint is chemical testing decontamination. Because the agents and test conditions are not identified in the public record, the remaining contamination risk could not be assumed away. Residues might persist in sheltered joints, enclosed compartments, surrounding soil, or other protected surfaces. But their location and persistence would have to be established through qualified testing. Before structural handling could begin, qualified specialists had to determine whether the aircraft could be approached and recovered safely. Public museum histories state that the bomber received the required chemical testing and was decontaminated before disassembly, but they do not publish the sampling sequence, clearance limits, or agents involved. The documentary record therefore supports a verified clearance process, not a universal rule that any positive result would automatically end the recovery. In the case of this specific bomber, the sweeps eventually granted clearance. The baseline requirement of safety was met, shifting the problem from hazard mitigation to physical planning. The recovery team was now authorized to interact with the metal. Clearance solved the legal and safety barriers, but the engineering reality remained daunting. The team was faced with a structurally compromised machine stranded in the remote Utah testing range. How do you extract a weakened test target from a proving ground after prolonged abandonment? In 1983, a museum recovery team faced a strict time window, defined by 3 decades of physical decay. The airframe had been abandoned in the Utah desert since 1953, and continuous exposure had transformed it from a rigid military machine into a fragile structure reacting to a hostile environment. At the Dugway Proving Ground, high-altitude terrain, lack of maintenance, and unchecked climate cycles drove heavy desert corrosion. Published accounts document prolonged outdoor exposure and extensive corrosion. They do not establish that severe vandalism stripped the aircraft or tore open its protective skin. If windows or access hatches were already open or damaged, desert wind could drive alkaline soil into the crew compartments and bomb bays, where dust would settle in the lowest points of the fuselage frames. The decay did not necessarily follow a single mechanism. Environmental exposure could drive pitting, crevice attack, and localized galvanic corrosion, where dissimilar metals met in the presence of an electrolyte. The aircraft's aluminum alloys and magnesium components were vulnerable, but the dominant mechanism would have required direct inspection to determine. Severe diurnal temperature swings forced the metal to expand and contract daily, mechanically stressing the factory rivets and weakening the lap joints. Ultraviolet exposure, abrasion, and age could weaken or remove protective finishes, leaving more of the aluminum alloy exposed. Even then, the metal was not literally defenseless. Its natural oxide film remained, while damaged coatings and trapped contaminants increased the risk of localized corrosion. When rare desert moisture or morning condensation interacts with the alkaline soil particles packed into the seams, an electrolytic cell is formed. This chemical reaction accelerates oxidation across the exposed duralumin. Hidden corrosion could develop inside seams, beneath coatings, or around fasteners, and magnesium parts could deteriorate rapidly once their protection failed. But the specific claims that the stringers corroded from the inside out and the engine components became brittle and flaked away remain unconfirmed without the original inspection record. The oxidation actively eats into the load-bearing surfaces, reducing the overall stiffness of the fuselage and the wings. This continuous chemical breakdown forced the engineering team into a rigid operational trade-off. They had to thoroughly map the decay to stabilize the structure before any lifting could be attempted. For the evaluating engineers inspecting the site in 1983, this internal degradation presented a strict handling limit. Moving a compromised heavy bomber requires the internal structure to support extreme point loads during jacking and rigging. The inspection required a tactile and visual survey of the main wing attach points and load-bearing bulkheads. Engineers would have treated white or gray powdery deposits around rivet lines as warning signs of corrosion. Those deposits could identify areas requiring cleaning and closer inspection, but they could not, by themselves, prove the severity of metal loss or determine a safe lifting point. The team had to physically map the interior frames, testing the lower fuselage to ensure the aircraft would not tear itself apart under its own weight once lifted off its landing gear. They had to determine if the internal spar network had succumbed to the same galvanic corrosion that ravaged the exterior. If the main spar was compromised, lifting the aircraft would cause the wings to fold and the fuselage to snap. The physical condition of the metal dictated the feasibility of the entire project. The surviving public record confirms the practical outcome. After chemical testing and structural assessment, the aircraft was judged recoverable, and the operation proceeded. It does not publish the detailed findings claimed here about deeply oxidized skin, degraded magnesium housings, intact central load paths, or spar thickness resisting alkaline moisture. Those structural conclusions remain unconfirmed. The airframe was surviving, but could it withstand being broken apart for transport? The recovered airframe is documented as serial number 44-86408, although the exact location and authentication history of its data plate are not established in the available public record. With the original straight flush already destroyed, the museum faced an institutional decision. How could a surviving substitute accurately represent that lost operational legacy? When an original historical aircraft has been destroyed, A museum may use a surviving airframe to interpret or commemorate its story. That is a curatorial choice, not a universal procedure known as stand-in airframe identity. Responsible interpretation preserves the substitute aircraft's true provenance, explains the change in markings, and avoids presenting shared dimensions or production data as proof that two airframes were identical. The shared delivery date was a striking coincidence, not a mandatory approval requirement identified by any source. The museum's stated rationale instead centered on the connections among Straight Flush, the 509th Composite Group, Wendover Field, Hill Air Force Base, and the state of Utah. During that mission, the crew assessed cloud obscuration at below 0.3 and transmitted the result to the primary strike formation. The institutional decision to merge these identities was a calculated curation trade-off. The museum gained a permanent physical representation of the combat unit, while accepting that the metal itself had no combat record. Straight Flush's silver plate conversion removed most defensive armament and armor, so the standard Block 55 substitute could reproduce the overall silhouette, but not every structural or equipment detail. In applying this curatorial substitution, the museum acknowledged that the surviving metal did not fly the weather mission. The verification process therefore focused on evidence discipline. Collection records confirm the serial number, service history, and delivery date of 44-86408, not a rivet-by-rivet equivalence with Straight Flush. The resulting display preserves the broad presence of a B-29, while the interpretation must disclose the differences between the two aircraft. The curatorial rationale was complete, but the physical problem of extraction remained. To make the commemorative display possible, the engineering team still had to move the massive aluminum structure across the state. The rigid geometry of a heavy bomber defines the boundaries of its extraction. The Boeing airframe possessed a wingspan of 141 feet 3 inches. The recovery operation faced a strict spatial limit because the destination lay over 100 miles over land. You cannot tow an intact strategic bomber across modern civilian highway infrastructure. The route from the Dugway Proving Ground to the Hill Aerospace Museum required navigating narrow, 2-lane roads, tight intersections, and restrictive highway overpasses. The operational constraint was absolute. The extraction team had to reduce the physical footprint of the aircraft to match the dimensions of standard highway transport trailers. The published empty weight for a standard B-29 is 70,140 pounds, but that figure is not the measured transport weight of this stripped and dismantled airframe. The handling problem combined unknown section weights, extreme volume, and the limited clearances of the overland route. The true challenge is the volume that massive weight occupies within a confined transport corridor. Furthermore, the handling procedures were severely complicated by the existing structural degradation. The logistics team had to rig and lift a fuselage already weakened by galvanic desert corrosion, without inducing fatal stress fractures during the breakdown process. To bypass the highway geometry limits, the military assigned the 2952nd Combat Logistics Support Squadron to dismantle the bomber for truck transport. Published accounts confirm the disassembly, but they do not identify every separation point or establish that the work occurred exclusively at original manufacturing joints. The defensible conclusion is narrower. The team divided the aircraft into transportable sections while supporting the weakened structure and preserving as much of the airframe as practical. The available recovery history does not document the exact order of jacking, bolt removal, tail separation, sling placement, or crane support. Those details remain unconfirmed and should not be presented as a recorded engineering sequence. Once the aircraft had been reduced to transportable sections, the components were loaded onto trucks and moved from Dugway to Hill Air Force Base. The published record confirms overland transport, but not the claimed wooden cradle design, tie-down pattern, convoy speed, or exact infrastructure clearances. The essential result is clear. In the fall of 1983, the dismantled bomber reached the preservation site for reassembly. At the preservation site, the restoration team turned from transport to reconstruction. Reassembly required the major sections to be supported, aligned, and joined without imposing unnecessary loads on the weathered structure. Public accounts confirm reconstruction for static display, but they do not document the specialized jacks, winching sequence, splice tolerances, or transfer of weight onto original landing gear described here. Once the primary airframe was joined, the absence of all original defensive hardware created the next visual compromise. The museum could display an authentic but incomplete test target, or install non-conforming substitute parts to restore the combat silhouette. The Curatorial team selected the visual completion path and fitted replica fuselage turrets, while the aircraft was displayed as Haggerty's Hag. Those additions restored the outline of a standard combat B-29, but not its internal fire control system or armament installation. They also created a later interpretive compromise, because the silver plate straight flush retained only its tail turret. The display therefore reproduced a recognizable B-29 silhouette rather than an aircraft identical to the Hiroshima weather ship. Before the final identity could be applied, the team treated corrosion, repaired damaged skin, and prepared the exterior for coating. Primer and paint reduced the metal's exposure to moisture and contaminants, but they could not permanently seal every joint or guarantee that hidden corrosion would never return. The coating system was one layer of preservation, supported by continued inspection and later restoration. After structural reassembly and stabilization, faint 6th Bomb Group markings observed on the metal informed the initial paint scheme. Based on those remnants and the historical documentation then available, the museum finalized the corresponding combat presentation. The painters applied the distinctive tail markings, squadron codes, and nose art corresponding to that specific unit. This early display decision established the airframe as a stabilized museum artifact, halting the physical decay and providing a cohesive visual narrative for the public. Structurally complete, the airframe awaited its final historical assignment. The final transformation required a curatorial trade-off between the established Haggerty's Hag identity and the straight flush story. Although the surviving airframe had no operational connection to the 509th Composite Group, the museum chose a complete aesthetic revision with stronger local relevance. The lost straight flush completed 11 training and 6 combat missions in the Pacific Theater. Its August 6th weather report guided final target selection for a mission already airborne. It did not authorize the atomic operation itself. After the airframe was scrapped in 1954, that record survived through documents, photographs, associated artifacts, and other aircraft of the 509th Composite Group. In 2015, the museum began the comprehensive aesthetic overhaul. Maintenance crews scuffed the established primer and sanded down the old squadron codes to prepare the aluminum shell for the new commemorative scheme. The execution of the final paint scheme drew on archival photographs and historical references, but it did not recreate every detail of straight flush as it appeared during the Hiroshima mission. The surviving aircraft belonged to a different production block, retained replica fuselage turrets, and carried a commemorative combination of straight flush markings. The painters recreated the name, insignia, and selected external details to communicate the aircraft's story, not to claim a perfect rivet by rivet or mission day reconstruction. This deliberate repainting process fundamentally changed the institutional function of the artifact. The bomber was no longer just a stabilized recovery project pulled from a desert testing range. The local consequence of this transformation was the successful and permanent preservation of a scrapped legacy through a surviving stand-in. The museum explicitly dedicated the newly painted aircraft to honor the 509th Composite Group, ensuring their unique operational history remained visible and accessible to the public. Today, the physical medal of serial number 44-86408 carries the external identity of the destroyed straight flush as a commemorative museum display. Its controlled environment reduces exposure and eases conservation, but does not halt decay. Corrosion, coatings, joints, and structural supports still require inspection and periodic intervention. One bounded question remains. How long can a static airframe carry the operational weight of a substituted legacy before time forces another structural intervention?